Hi 8th grade, this is Miss B here. We are officially in our last unit for the 8th grade school year. And today we're going to be looking at lesson 6.01. We're going to learn the Pythagorean theorem and its converse to prove that a triangle is in fact a right triangle. So let's start by reviewing some right triangle vocabulary. So in any right triangle, we have this square corner, which indicates that it is a right angle or 90-degree angle. In a right triangle, we have what are called two legs. And these two legs are the shorter sides of the right triangle. The longest side of the right triangle is directly across from the right angle, and it is called the hypotenuse. So again, the hypotenuse is across the right angle, and it is the longest side in a right triangle. Take a moment to write down the definition of the Pythagorean theorem before we look at an example and get a little bit more into how to use it and when to apply it. So the Pythagorean theorem is the square of the length of the hypotenuse of a right triangle, which is equal to the sum, so when we add them up, the sum of the squares of the lengths of the other two sides. Pause the video and finish copying it down before we look at an example. So as we work and look through our examples today, you're going to want to try to imagine that we're going to have this imaginary square on each side of our right triangle as depicted in this image that's on the bottom half of your handout. So for example, this vertical side that's labeled A would have a side length of 3 since we have 3 units. And if we were to square it, or if you imagine the square here, the area of A would be A times A, or 3 times 3, which would give us 9 square units. So that's what we're going to be talking about as we're squaring the sides of a right triangle today. So turn over to the next page where you have a similar example that we have here, and we're actually going to count up the squares and see what relationship the two smaller ones have with the larger square. Pause the video and take a moment to answer questions 1 through 5 before we share out together. So we're going to prove that the Pythagorean theorem shows that the length of the area created by the length of the smaller two sides is equal to the sum of the larger side, or our hypotenuse. So the area of the smallest square, which would have a side length of 3, right here, this vertical side, is 9 square units. The area of the medium-sized square, which has a side length of 4 in our triangle, would be 16 square units. And the area of the largest square is 25, since it's 5 by 5. The area of the small square and medium square together, if we add 9 and 16, gives us 25. And what do we notice about the relationship between the 3 triangles is that the sum of the small and medium square is equal to the area of the large square. Which then brings us to the formula for the Pythagorean theorem, which is that a squared plus b squared, and a and b are our two legs, is equal to c squared, which is the hypotenuse. So really you can think of the Pythagorean theorem as leg squared plus leg squared equals the hypotenuse squared. So if we square both legs and add them together, it'll be equal to squaring the length of the hypotenuse in that right triangle. Follow along on the guided practice page as we look at examples in which we'll find the missing side of a triangle, of a right triangle, given any other two sides. So in example 1, we're going to be finding the length of the hypotenuse. So the first thing that we should do is label the missing side. So in the formula, a squared plus b squared equals c squared, our hypotenuse is represented by c. So I'm going to go on ahead and write down c as the missing side. And I know it's the hypotenuse since it's directly across from the right angle. So once we've labeled that, we can go on ahead and write down the formula as our first step. A squared plus b squared equals c squared. So we have 3 and 4 as our two legs. It doesn't matter which number you substitute for A or for B, since we're just going to be adding them together after we square them. So we have 3 squared plus 4 squared is equal to C squared. Again, we don't know what C squared is just yet. So now we're going to solve for C. So 3 squared gives us 9, 4 squared gives us 16, and we still have C squared on the right-hand side. So to solve, or to get C by itself, we're going to add 9 and 16 to get 25. And the square root of 25 is going to give us the answer for C. So since 5 times 5 is 25, the value of C, or our hypotenuse, is 5. So we've gone ahead and applied the Pythagorean theorem to find the hypotenuse of a right triangle. In this next example, we're going to be finding the length of a leg given one of the legs, one of the two legs, and the hypotenuse. So in this example, first thing we'll do is label the missing side. So in A squared plus B squared equals C squared. C is our hypotenuse, and if you look across from the right angle, we're given the hypotenuse already. So we need to know that we're solving for A or for B, one of the two legs. So the first thing we'll do is label. The next thing we'll do is write down the formula, A squared plus B squared equals C squared, and substitute our values. This is where you need to be very careful. One common error is that whenever we're substituting, we'll just keep everything on the right-hand side. So I've decided to label my leg A, the missing leg. So I have A squared plus the other leg squared, which is 5, is equal to my hypotenuse squared. And we have the hypotenuse in this example. So now we're just going to evaluate and solve for the missing side. So A squared plus 25 is equal to 169. So now we need to use some inverse operations to get A squared by itself. And the way that we're going to do that is by subtracting 25 on both sides to bring it to the left-hand side. I said side quite a few times, didn't I? So we have A squared equals 169 minus 25, which is 144. And the square root of 144 will give us A. So the missing leg is 12 units. Take a moment to work through example 3. Now, be mindful that the triangle's orientation isn't normally how we would look at a right triangle. So just be very careful. Look for that right angle and think about which values you're given and which value you need to solve for. Are we solving for a leg, or are we solving for the hypotenuse? So take about 1 or 2 minutes, pause the video, and unpause it when you're ready for the solution. So to find the missing side of the triangle in example 3, which is the leg that we're solving for, so I didn't realize I had already labeled A or B before I asked you to look at this yourself. So same steps, write down the formula, substitute the values, and use inverse operations to get the value of the leg by itself. So in this case, we have a leg of 8 units, another leg of 6 units, and our hypotenuse is 10 units. The next part of our lesson for today is how to use the Pythagorean theorem to prove that the 3 given sides of a triangle makes that triangle a right triangle. So if we substitute these values and we